Pick all this crap off my
I
neck.
feel famous now.
Okay, so by conditional statement, we had conditional statement. Conditional statement is if then, if this then this. Biconditional, what does bi mean? Prefix.
Dose.
Two. We're going to have two statements that we're going to combine into one. So the first statement is the conditional statement, the if then statement, and it must be true. When you converse, what's converse do? When you converse your statement, that also must be true. And then if they are both true, you can have a biconditional statement. In other words, it can work both directions no matter how you word it. And instead of having an if-then statement, you're going to have something if and only if something. So here's an example. All right, Skylar, this is what we're looking at here. So the conditional statement we're starting with is if a polygon has three sides, then it is a triangle. So get your logical mind on, is that a true statement?
Uh-huh.
If it has three sides and it's a polygon, then it's a triangle. Okay, we know that's a true statement. So the converse of that, remember I've flipped the information inside. So if a figure is a triangle, then it has three sides. Now think of it that way. If it is a triangle, does it have three sides? Yes. Both the conditional and the converse are true. If both are true, that means you could say it or write the statement either way. Okay? And in that case, we can create a biconditional statement. So it doesn't start with if, it has if in the middle. It could be a figure has three sides if and only if it is a triangle.
That wouldn't work with squares and quadrilaterals, though.
Correct.
Because
That's
the
why
converse
some
doesn't
statements, conditional and converse, will work and some will not. So you will have to read to make sure that your original, conditional, and your converse both are true in order for the biconditional to be created. But the main thing is that your words if and only if are here in the middle of it instead of having an if-then statement. Okay, so this is what we're looking at for a biconditional statement. Again, the abbreviation on that can be, if you want to write it and not have to write all the words, you can do if and only if with two F's. Okay, and you noticed already that I abbreviate statement like this just to save space and make my letters a little bigger so y'all can see them better. Okay, we'll practice some of those in a second. Deductive reasoning. Deductive reasoning, unlike inductive reasoning, inductive was using examples and things from the past to make prediction. Deductive reasoning is using statements, facts, thinking logically to form conclusions. So we're still forming conclusions, we're reasoning out something, but we're using actually true statements and facts. So there was inductive reasoning. Deductive is like deducing things from the information that you're given. And then we'll have I would blank on the other reasoning. Indirect reasoning. So there's three that we'll talk about. So inductive, deductive, and then we'll have the indirect later. Okay, so do we have these written down, and are there questions on the vocabulary part? Along with deductive reasoning, there are two things that are on the paper that I gave you for notes that we're going to look at. So you'll need your highlighter, and we're going to talk through each of these. Okay, first is a law of detachment. Second is a law of syllogism. Sounds weird. But law of detachment, if you'll take your highlighter and highlight each of those names, law of detachment, law of syllogism. These are notes that we will fold and just glue into your journal. That way it's already kind of written for you. Okay, here's the law of detachment. Remember the P's and Q's? If P, then Q. For the converse, we switch that. If Q, then P. So those are just thoughts that are going in the if-then statement. For the law of detachment, you have two things. You have if P, then Q. If that is a true statement, sometimes you can detach those two statements and make two complete sentences. You can have the hypothesis in a sentence, and then your conclusion can be drawn in a sentence form. So if P to Q is true, then P is true by itself, and Q is true also. In other words, here's an example. Okay, if a figure is a square, then it's a rectangle. Conditional statement. So I'm going to take that conditional statement. It's a true statement, and the figure is a square. I know my figure is a square. What else can I conclude?
It's a rectangle.
My figure is a rectangle. So you have The figure is a square stated by itself. I can detach it from the fact that if I know this is true, then I know my figure is a rectangle. Okay, it's really all about just kind of training your mind to think in a logical kind of way. These are just different logical methods. So let's do the next two. These are examples. So this is my true statement. If a dog goes out to play in the woods, then the dog gets dirty. If then conditional statement. Okay, this is what I know. Carrie's dog Spot went out to play in the woods. What can I conclude, Kyle?
From Carrie's dog.
Mhm.
Goes out to play in the
Based on this statement, because Carrie's dog went out in the
it'll get
woods.
dirty.
Say it again.
It'll get dirty.
Then it will get dirty. Okay, so I have a statement of it. The dog goes in the woods. My detached statement is the dog gets dirty. So fill that in on the blank there. Law of detachment. Here's another example. If an animal is an ant, then an animal is an insect. It's already a conditional statement. If this, then this. Based on that information, I know that a carpenter ant is a type of ant. Tyson, what conclusion can I make from my conditional statement?
That the animal is an insect.
So since I know the carpenter ant is an ant, because of this, I know the carpenter ant is an insect. That's your conclusion. Okay, I'm going to go back to that statement. If an animal is an ant, then an animal is an insect. What if my statement said an animal is a bear? Can I make a conclusion based on that information?
It's not an insect.
Can you imagine a giant
Okay,
carpenter
so
ant
an animal is a
stealing that?
butterfly. Can I make a conclusion based on that statement?
Yes.
So you're only using this statement. If I know it's an ant, then it's an insect. I know nothing else.
Oh.
Yes,
no.
we know that a butterfly, right, is an insect. I think
Yes.
so. But we know bear is not. But still, only based on this statement is what I know and I can use for a fact. Okay, so based on this information, then I know this. I detach it. So sometimes you can make a conclusion based on your information, sometimes you can't. Even if we know otherwise. Okay, so basically you want to think of these reasonings like you're in a courtroom and you have to prove something is factual or prove something is true. So if you went in saying that you had a butterfly and you were trying to prove it's an insect, this statement does not prove that. This is a true statement, but this statement does not prove the butterfly is an insect. Okay, only by the facts that are given. Okay, now law of syllogism. I'm going to kind of also talk about this with the P's and Q's, but then I'm going to do it like with numbers as well. So, law of syllogism, if a thought leads to another thought, and that's true. If P leads to Q, and that's true. And Q leads to a third thought, R, and then that's true. Then the first initial thought leads to the final thought of R. So if P leads to Q and Q leads to R, then P leads to R. Okay, I'm going to do that kind of as I talk about this example right here. Oops, off the page. So, my first thought. First thought. If it's after 5 p.m., leads to my second thought. Then it's almost time for dinner. Okay, I'm going to repeat my second thought. It's almost time for dinner. What am I going to start doing?
Stop watching TV.
Yeah, so stop watching TV. That's my third thought. Oh, you need to circle that. Oops. Okay, first thought leads to second thought. I repeat my second thought. It leads to the third. So if that is the situation and these were repeated, then I can rewrite by the law of syllogism my first thought leading to my third thought and skip in the middle man. Okay, so if it's 5 p.m., then I should stop watching TV. Okay, but that only happens if these two thoughts are the same. So on your paper, I do want you to highlight. So the then part, the conclusion of the first statement, which is what they underline. If it's 5 o'clock, it's almost time for dinner. Highlight in the next statement the hypothesis. If it's almost time for dinner, then it's time to stop watching TV. And then after these are highlighted, if they're exactly the same, you can have your first thought lead to your last. So if it's 5 p.m., then I should stop watching TV. Law of syllogism. 3 things will be involved, and they have to be in that specific order. The first leads to the second leads to the third, so the first leads to the third. Okay, let's practice that on these next 2. If it's raining, then the sidewalk will be wet. If the sidewalk is wet, then the sidewalk will be slippery. Okay, if it's raining, what's my conclusion?
Sidewalk will be slippery.
Eventually, yes. On the first statement, what's my conclusion?
Oh, the sidewalk will be wet.
Yes, I want you to highlight with me on the notes. But yeah, basically, you had the whole idea. So my next statement is the sidewalk's wet. What's my conclusion then?
Sidewalk will be slippery.
Okay, so did I highlight the same exact thing right here and here?
Mm-hmm.
Yes, so I can ignore these because I can go straight from it's raining to the sidewalk will be slippery.
So, by the law of syllogism, what's the point of showing our work on math every step through? If we can get from point A to point D super fast, and why go to point B and C?
So we will learn to use this in proving things. Again, all of this mindset is learning to prove that something is true. So let me do a quick little example right here next to it so that you can see the geometry part.
I'm just going to law of syllogism.
Segment
That's the
AB
short
is congruent to segment CD. Segment CD is congruent to segment XY. What can you conclude?
That's not a segment. That XY is not a segment. Then
This
AB
one
is
leads congruent to
congruent.
this.
XY.
This one lays congruent to this, so this one
Is congruent to XY.
is congruent to this one. That's kind of where we're headed with that. If I have 2 things congruent or added to or something like that, then you can lead it to a third thought. So it's getting there. It's just training our mind through words to think about the geometry. All right, next one. So if the temperature is below 58 degrees, then the heater will come on. What's our conclusion? It's below 58 degrees in that statement. What's the conclusion, Holly?
Then the air outside will be dry.
Close. Only in the first statement.
Oh, then the heater will come on.
Then the heater comes on. Good. I'm just still having y'all highlight the conclusion on the first one. Okay, what is the hypothesis in the second equation, Kyle?
If the heater comes on, the air inside will be dry.
And the conclusion is the air is going to be dry. So again, oops, I'm still off of the board. Again, I have the highlighted things. Are they exactly the same? Yes. So when I say if the temperature is below 58 degrees, my final conclusion can be what, Tyson?
The air inside will be dry.
Okay, good. So you guys fill those in.
Not as shriveled and dried up as my little bit.
And that is your notes for now. We are going to fold those in half and we're going to glue them in your journal. And then I have some of the homework that we're going to do a problem together on.